Hi friends, welcome to GMK tutorials. In this video, we are going to see about the image smoothing in case of the frequency domain application. Generally, frequency domain means that frequency domain smoothing means that here two important points is nothing but like sharp edges. Sharp edges contribute high frequency. Sharp edges means that high frequency. Suppose if you want to smoothen the images means that we can attenuate the high frequency ఇప్పుడు మనకి ఇమేజ్ లో ఏదైనా షార్ప్ ఎడ్జెస్ ఉన్నాయంటే దట్ ఈస్ నథింగ్ బట్ చాలా ఇలా ఉంటాయి. దీన్ని స్మూతింగ్ చేయాలంటే ఇలా చేయాలి. అంటే ది స్మూతింగ్ మీన్స్ దట్ we can attenuate this high frequency component means that high frequency component attenuate చేయాలి. హై ఫ్రీక్వెన్సీని అటెన్యూట్ చేసే ఫ్రీక్వెన్సీ ఏముంటుంది? జనరల్ గా we can call as a low pass filter. Low pass filter attenuates or stops the high frequency come. Therefore the image ఏమవుతుంది మనకి స్మూత్ గా కనిపిస్తుంది. So that is nothing but smoothing in the frequency domain అని చెప్తాం. So that is a important thing, right? So let us move on to the low pass filter consideration point of view. So we can define in case of the so at the same time one more important point is nothing but in case of the image smoothing point of view also we have three types of filters are there. Three types of low pass filters there. That is nothing but three types of filters are there. That is nothing but ideal low pass filter, and second one is nothing but ideal LPF and Butterworth LPF, and third one is nothing but Gaussian. Gaussian LPF. Gaussian. These are the three low pass filter types. LPF types, low pass filter types. E low pass filter types low basically for Butterworth high pass filter means that it is nothing but it is completely depends on the filter order. Okay, filter order is a very important. If the order of the filter increases, it approaches to ideal low pass filter. If suppose order of the filter is decreases means that it approaches to Gaussian characteristics. So these are some of the characteristics of the Butterworth filter. Okay, let us move on to the next one. That is nothing but ideal LPF. So ideal generally low pass filter means that which allows only low frequency component. That is one of the most important point you have to remember each and every time. Okay, so generally the ideal low pass filter can be represented as, so these are the 2D filters, second order low pass filter. That's why it is nothing but h of u comma v. U comma v is nothing but frequency domain variables. H represents a transfer function. So that is equal to mathematical we can represent as, so 1 for d of u comma v less than d naught. Okay, so 0 for otherwise. This is a mathematical representation for ideal low pass filter. Okay, so where d naught is nothing but some positive constant, d naught is nothing but some positive constant, where d of u comma v is nothing but distance between u comma v and center of the rectangle and center of the frequency rectangle, center of the rectangle. That is the some of the important observations in case of the ideal low pass filter. At the same time, d of u comma v can be represented as d of u comma v is equal to, so it is nothing but u minus p by 2 whole square plus v minus q by 2 whole square. So obviously there is a question mark each and every person mind. So what is meant by p and what is meant by, so p comma q are padded sizes. Okay, so p comma q are used for padding, padding sizes. Okay, so that is a very important. Generally, from the definition of the ideal low pass filter, what it means is, suppose if you are taking the ideal characteristics point of view, it can be represented as, ideal low pass filter can be represented like this. So where it is nothing but d naught, so this can be represented as a d of u comma v. Okay, d of u comma v. So it can be represented as h of u comma v. So the amplitude of this transfer function is nothing but 1. So in case of the images point of view, how you are going to represent this one? Suppose if you are taking this image is generally called some rectangular shape. Okay, rectangular shape. So d naught is some positive constant from center of the pixel. Therefore, let it be considered like this. So in this consideration, from 0 to d naught has a radius having d naught. At that time, this function is value is equal to 1. That means it maintains a value of 1. Therefore, this part is nothing but it represents as some white color. Okay, this represents as some white color. So this represents some white. Color. So in the remaining surrounding area can be represented as a black. So this is a representation of the ideal low pass filter. Okay, so this is very important for the low pass filter characteristics point of view. Moreover, this low pass filter is used to attenuating the high frequency combo. It is used for attenuate the high frequency. That means if you are attenuating the high frequency, means that obviously high frequency means that image is smoothing. Image smoothing achieved in case of the frequency domain by using a ideal low pass filter. So what is the drawback in case of the ideal low pass filter? The ideal low pass filter characteristics may not be exhibited same in the practical scenario. That is a drawback. So some deviations obviously there. Therefore, some loss of information will be present in the characteristics of the ideal low pass filter. Okay, thank you for watching GMK tutorials. If you are subscribe our videos, thank you.